An equation is just two algebraic expressions that are set equal to each other by an equal sign. So when we combine like terms in order to simplify and then solve a multi-step equation, we can follow the same rules that we would for combining like terms in an algebraic expression. First, we would organize all the terms in the algebraic expression using some kind of categorization system. So you can either use shapes, underlining, however you want to show the different terms that go together. So you have 8x and negative 3x. Positive 5 or plus 5, so it's a constant, and minus 2. Treat each term as a positive or negative. So we have positive 8x, positive 5, negative 3x, negative 2. Add all sets of like variables. Just add the coefficients. So 8x plus negative 3x, which is going to give me 5x. 8 plus negative 3 gives me positive 5. Do the same thing with all of my constants. Positive 5 plus negative 2 gives me positive 3. My final answer is 5x plus 3. Can that be combined any further? Could the answer be 8x or 8? Think about why or why not. Let's try one problem together and then one on your own. So I'm going to take t plus 11 minus u minus 14u plus 13t. I want to categorize first. So I see t's, I see constant, and I see sets of u. So I single underlined all my sets of t, double underlined my constants, triple underlined my sets of u's. T plus 13t, so that's 1. So there's a coefficient of 1 in front of the t, so that's 14t. We take our u's, negative 1u plus negative 14u. Remember, there's a 1 there. So it gives me negative 15u. And the constant's just 11. On your own, try the next problem. Remember, as a tip, organize your algebraic expression so that the variables appear first, followed by the constants. Variables should be listed in alphabetical order and in order from biggest exponent to small exponent. So you'd have A, B, C as far as variables go, but you would have a squared plus a. You'd put the exponent first. So an exponent of 2 comes before an exponent of 1. Up to this point, we've only solved two-step equations. With a multi-step equation like this, think about what you need to do first. How would you solve this problem? You need to combine like terms first. So first step with an equation, combine like terms. Do this on each side of the equation. So I'm going to combine my left side first. My right side's already combined. So I have 8x, negative 2x, constant of 2. 8 minus 2 gives me 6. 6x plus 2 equals 38. The other side's changed. Now I need to look at what I am left with. I need to decide what type of equation you have after you simplify the equation. I've simplified the equation. I'm left with a two-step equation, so I'm going to treat it like a two-step equation. So I need to solve. First thing after my variable is I'm multiplying by 6, then I'm adding 2. So when I undo that, I need to subtract 2 and divide by 6. So I subtract 2 from both sides. 6x plus 2 minus 2 gives me just 6x. 38 minus 2 gives me 36. Next it says we're going to divide by 6. I'm going to divide by 6 on both sides. 6x divided by 6 gives me just x. 36 divided by 6 gives me 6. My solution here is x equals 6. If I plug that value in to any step of that equation, I would get a true statement. Let's try a couple problems together. First thing you need to do is simplify both sides of the equation. So I'm going to take my left side here and simplify. I'm going to categorize all of my like terms. I'm going to combine 10x plus negative 3x plus positive 2 to get 9x. Negative 5 plus 3 plus 2 gives me 0. That equals 81. I don't need to simplify 81. That's really 9x equals 81. So at this point, after I've simplified or combined like terms on both sides, I need to see what type of equation I have. In this case, there's only one operation affecting my variable. So I just need to ask myself, what's happening to my variable? I'm multiplying by 9. So it's a one-step equation. I don't need to think about the order of operations. Multiplying by 9, so I need to divide both sides by 9. That's going to leave me with x equals 9 as my solution. Remember, to check that, I could plug plug 9 in for x, either at the simplified or unsimplified version of this equation to get a true statement. We'll try the next problem together. So I combine all like terms. So only the left side needs to be combined. So I have 2x and positive x. I have positive 5 plus negative 3 plus positive 2. 2x plus x gives me 3x. 5 plus negative 3 plus positive 2 gives me positive 4. The left side does not need to be simplified. It's already negative 11. Now look at this. There are two things happening in my variable. I'm multiplying by 3 and I'm adding 4. That's a two-step algebraic equation. So I need to treat it like so. I'm going to write out the operations that are happening in order of the operations. I need to multiply by 3 and add 4. So to undo that, I'm going to write the inverse operations and go backwards. I'm going to subtract 4 and then divide by 3. Remember, this method lays out the order of operations going from bottom to top, times 3 plus 4, and then lays out the inverse operations, minus 4, divide by 3. So I subtract both sides by 4. So I subtract 4. I'm left with 3x on the left, negative 15 on the right. Next it says to divide both sides by 3. 3x divided by 3 gives me x. Negative 15 divided by 3 gives me negative 5. Again, if I substitute the solution of negative 5 into the variable at either the simplified or unsimplified version of the equation, I should get a true statement. This is when you need to combine like terms on either side of the equation. So when you're simplifying the algebraic expression on the left versus the algebraic expression on the right. When you need to combine like terms across the equal sign, you need to follow an extra little step. The trick here is that you always want to get all of the variables on one side. If you can do that, then you can follow all of your one-step or two-step equations rules once the equation itself has all the variables on either left or right side. To do this, combine like terms. So combine like terms on left and right. So we have 6x equals 32 minus 2x. Left and right are already combined. There's nothing I can do. I can't move one term to the other side of the equation yet. In order to do that, we need to use inverse operations to combine all sets of variables on one side of the equation. You only need to move the variables to one side. The constants will take care of themselves using our simple one- or two-step equation rules. So I see 6x and I see negative 2x. I'm going to move the negative 2x. The opposite of minus 2x is plus 2x. If I add to both sides, it cancels on the right and it turns 6x into 8x on the left. Now I've turned into one-step equation. So I need to decide, based on what I'm given, what type of equation. I have a one-step equation, so I just need to do one operation in order to solve. What's happening to my variable? I'm multiplying by x, so I'll divide both sides by x. 8x divided by 8 gives me x. 32 divided by 8 gives me 4. Let's try a problem together. First, simplify each side of the equation. So I see negative 3x, positive 2x. Negative 4x, negative 12 is a constant, 6 is a constant, 45 is a constant. So I've categorized, now I can simplify the left side, simplify the right side. If I combine my variables on the left, I have negative 3 plus negative 3x plus positive 2x, which gives me negative x or negative 1x. My constant is negative 12. It stays the same, it does not combine with anything. On the right side, I have negative 4x and then two constants, 6 plus 45. So I should end up with negative 4x plus 51. All I really need to do at this point is move all of my variables. I don't need to worry about moving my constants. By following my 1 and 2 step equation rules, the constants will take care of themselves. I'm going to move the 4x. In order to move my set of variables from one side to the other, I need to use my inverse operations. To get rid of minus 4x, which remember, negative 4x is the same as subtracting 4x, I'm going to add 4x to both sides. Negative 4x plus positive 4x equals 0. 0 is the identity for addition-subtraction. That means we've canceled the term accurately. If I add to both sides, I end up with positive 3x minus 12 equals 51. Look at the equation. Ask yourself, is this a 1 or 2 step equation? We have a 2-step equation left. All the variables are on one side. I can solve this. So I need to add 12 to both sides. As generally speaking, we take care of addition subtraction before multiplication division. Remember, we're doing the order of operations in reverse. If I divide both sides by 3, I end up with x equals 21. On your own, try the next problem. Remember to combine like terms using the regular operations, and then move all of the variables to one side, either to the left or the right, using your inverse operations. The only time you need to use an inverse operation is if you move a set of variables from one side of the equation to the other.